video, I have shown you guys how can we find the truth table for the given expression using this logic diagrams, logic gate diagrams. Now here you can, if you don't like this method, you can actually use another method to solve this one. Like you can bring the exact same answer using another method. Now let's see how to do it. So here I'm going to erase this diagram. And I'm going to create some more tables, like one for the x bar y, and okay, let me use a different color. One for the x bar y, and one for the y bar z bar, and one for the xyz. Okay, so how do we do it? First, let's write this one down. So for given expression is x bar y, and when you take x bar and with y, what's going to be the solution? What's going to be the answer? That's what you have to look at. So here x is 0, right? If you bar that, that's going to be 1, and 1 and 0, that's going to be 0, because in AND gate, if you have just 0 in any place, that's going to make the whole thing 0. So that's what you have to look into. Here x bar again, that is going to be 1, and the 1 and 0, that's 0, and x bar is 1, 1 and 1, that's 1, and x bar is 1, 1 and 1, that's 1. X bar is 0, 0 and 1, that's 0. X bar is 0, 0 and 0, 0. X bar is 0, 0 and 1, 0. X bar is 0, 0 and 1, 0. Okay, so we found the first one. Now let's look at the second one. If we have y bar and z bar, so again, if we have 0 at any place, like if we get y bar and it's 0, that's going to make the whole thing 0. If we take z bar and it's 0, that's going to make the whole thing 0. Now let's look at this y and z. Yeah, if I take y bar, 0, y bar is 1 for the 0. So this is 1, 1. So the answer is 1. This is 1, 0. So this is 0. 0, 1, 0. 0, 0, 0. 1, 1. It's going to be 1. 1, 0. That's going to be 0. 0, 1. That's going to be 0. 0, 0. That's going to be 0. And the last one we have is xyz. For this one to be 1, all of the 3 has to be 1. If you have 0 at any place, that's going to make the whole thing 0. Now let's look at if you have 3, 1 in any place. This one definitely 0. This one, whole 3, like we have 0, 0, 1, that's 0. This is 0, 0, 0, 0, 0. Only the last one has 3, 1. So that's going to make this one 1. And the final expression, that our function is actually addition of all of these. So this is an OR gate, like we are doing OR gate to all 3 things. In OR gate, if you have just 1, that's going to make the whole thing 1. So here we have 1 here, so this is 1, and this is 0, so this is going to be 0, and here we have 1, that's going to make this one 1, and this is, here we have 1, so that's going to make this one 1, and here we have 1, that's going to make this one 1. This all of them 0, this is 0, all of them 0, 0, this is the last one, we have 1, that is 1. Now let's compare this one and the answer we got from using logic gate. You can see it's exactly the same answer, right? So this is an alternative method, and this is the method preferred. That's the method I did. That's the one preferred when you have complex expression given. I'm going to actually do one more example. For that one, you definitely have to use this one because that's a complex one. You cannot draw and find it out. Like, it's going to be hard if you do that. So I'm going to create a new page for it. Okay, let's write the expression. So let's say if we have expression given like g is equal to xy plus x bar plus z times y plus z bar. So here we have how many variables we have. We have x variable, y variable, and z variable. So if you have 3 variables, this is going to be 2 power 3, so we are going to have 8 combinations. Let's make the table for it. 1 for the x, 1 for the y, and 1 for the z. Okay, so this is x, this is y, this is z, and when we have 8 combination, we can just put 4 zeros first, 4 1 like this, and then 2 0 2 1 2 0 2 1, and then this is 0 1 0 1 0 1 0 1. Now we got the 8 combination. Now the next thing is we take all the expression individually, like x y and x bar z, y plus z bar. We take individually and find them out. We find the truth table for it. Okay, let's take one by one. So let's take this xy first. xy, I'm taking the sy. So in order to make this xy 1, both of them has to, x and y has to be 1. If you have 0 at any place, it's going to make the whole thing 0. So here 0 0, that is 0, 0 0 0, and then 0 1, that's going to be 0, 0 1 0, 1 0 0, 1 0 0, 1 1, that's 1, and then 1 1, that's 1. Okay, now we have written a truth table for the xy. Now let's try that one for x bar plus z. X bar plus c. The x bar plus c act like an OR gate. In OR gate, if you have just 1, that's going to make the whole thing 1. So let's look at this. X bar. If you complement this 0, that's going to be 1. So 1 plus 0, that's 1. And then complement this 0, that's 1. 1 plus 1 plus 1, 1 plus 0, that is 1. And then complement this 0, 1 plus 1, that's 1. Complement this 0, 1 plus 1, 1. Complement this 1, that's going to be 0. 0 plus 0, that's going to be 0. And then complement this 1, that's 0. 0 plus 0, 0. Complement this 1, that is 0. 0 plus 1, that's 1. And then complement this 1, that's 0. 0 plus 1, that's 1. And that's the truth table for x bar plus. Oh my god, that's you know what, this x bar plus z, I put it for x bar plus y, so this is wrong. I have to redo it. So this is actually x bar plus z. Let me erase this and write it again. Okay, so x bar plus z, let's do it again. Complement this x, that's 1. 1 plus 0, that's 1. Complement this x, that is 1. 1 plus 1, that's 1. Complement this x, that is 1. 1 plus 0, that is 1. Complement this x, that's 1. That's 1 plus 1, that's 1. Complement this 1, that is 0. 0 plus 0, that is 0. And then complement this 1, that's 0. 0 plus 1, that's 1. And then complement this 1, that's 0. 0 plus 0, that is 0. And then complement this 1, that's 0. 0 plus 1, that is 1. This is the truth table for x bar plus z. Now the one more things we have left, that's y plus z bar. Y plus z bar. Let me use a different color for it. Okay, so y plus z bar, this is also OR gate, so we had to just have 1 1 to make the whole thing 1. Let's look at this one. Here y plus z complement, so if we complement this 0, that's going to be 1. So 0 plus 1, that's going to be 1. And then y z complement, so this 1 complement, that's going to make this one 0. 0 plus 0, that's going to be 0 right here. And then y plus y is 1. 1 plus 0 complement, that's 1. 1 plus 1, that's 1. And then 1 plus 0, that's going to be 1. And then we have 0, and the complement of 0, that's 1. 0 plus 1, that's going to be 1. And then 0, and the complement of 1 is, that's 0. 0 plus 0, 0. 1, and then complement of 0, that's 1. 1 plus 1, that's 1. And then 1, complement of z, that is 0. 1 plus 0, that's 1. Okay, now we have found out the truth table for y plus z bar. Now I'm going to take a truth table for x bar plus z and y plus z bar, the combination of these two. Let's look at that. Let's write this expression right here. So this is x bar plus z and then y plus z bar. So we are just ANDing these two. If we AND, if one of them is 0, that's going to make the whole thing 0. So 1 and 1, that's 1. 1 and 0, that is 0. 1 and 1, that's 1. 1 and 1, 1. 0 and 1, that's 0. 1 and 0, that's 0. 0 and 1, that's 0. 1 and 1, that's 1. Okay. Now the final thing we have to do is we have to just OR this expression with xy. And when we OR, if we have just 1, that's going to make the whole thing 1. So 0 and 1, that's 1. 0 and 0, that is 0. 1 and 0, that is 0. I mean, 1 and 0 is 1. 1 plus 0, that's 1. Okay. 0 plus 1, that is 1. 0 and 0 plus 0, that is 0. 0 plus 0, that's 0. 1 plus 0, that's 1. 1 plus 1, that's 1. And this is our final answer. This is our expression for the given expression. This is the truth table for the given expression. And that's it for this video, guys. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.